All right. Well, I'm going to ask everyone to please mute themselves if you've not yet done that. And we will begin. Glenn, you hit record? Okay, terrific. Welcome. Welcome back to our regular guests. Welcome to new guests who have not been here with us today, and welcome to those watching on YouTube. We're thrilled to be here with you. I am proud to introduce Glenn Grossman. I am going to be the moderator for today's program. So if you have questions, you can send them directly to me in the chat and I will work to get them in the queue. We have a bunch of great questions that came in this week, so we'll start with that. But before we get to the questions, I want to introduce our host, Glenn Grossman. Glenn is an epidemiologist with over 20 years of experience. While pursuing his doctorate in epidemiology at UNC Chapel Hill, Glenn served as an epidemiologist on staff at the UNC Infectious Disease Clinic for 2 years and taught epidemiology and advanced analytics at Duke Medical School and UNC. He has been involved in epidemiology projects with Medicare, Medicaid, Veterans Health Administration, Military Health Service, the CDC, and other programs in the United States and outside of the United States. He is currently Senior Director of Outcomes Research and Epidemiology at Novartis, but all views expressed today are his own. So, Glenn, what has happened in our country since we were last together last week? Seems like every week you have some new and different news for us. So what are the current hotspots in the United States and also beyond?
Hey, Becky, thanks for asking. That's a great question. Give me 1 second. I forgot to elevate you to co-host. There, now you have full hosting authority.
Thank
you. I'm gonna share my screen so you can see what we're looking at. So as you can imagine, after the states have opened, many states opened before they were ready to open. And so we have seen an increase. We've seen the beginning of an increase in a bunch of different states. Let me start. You can see where the hotspots are currently around the United States. There's some of the bigger ones. Arizona is becoming big. There's a difference between the absolute number of patients in some of these locations versus the rate of new infections. So the reproductive rate, this R value, is different versus the absolute number of patients. So in New York, for instance, there's still 1,000 patients a day or so that are new cases. But at the same time, the R value is much, much smaller than it was a couple months ago. And so they're doing pretty well. But New Jersey and New York are not out of the woods yet. There's still quite a lot of cases, even though the R value itself is low. But you see on this chart, we're still seeing over 400 new patients a day, new positive cases a day. But there's some outliers that are not only having large numbers of people, but the rate is increasing in terms of the number of new cases. So Florida is an example of this, Texas, Arizona, California. I'll get into that in a second. But like I said, I think there were 146,000 new cases just in this last week alone. So it's a little bit less than the week before, but still quite high. The difference is that we're seeing a sharp decline in the Northeast. So you'll see up here, and that's continuing to decrease. And so that's sort of hiding because the numbers were so high. It's sort of hiding what we're seeing in other parts of the country. So the Midwest is also doing better than it was. But so really now the outbreak has moved and is moving towards the south of the United States and the west of the United States. And so here's some examples over here that we're looking at in the south and the west. But so Louisiana is still right on the verge. It's not increasing rapidly, but it looks like an R value of about 1, maybe a little bit of an increase. But Texas, you can see, is going up. And so that is going to require mitigation. Look at this, the shape of Arizona. You saw Arizona on this map wasn't very large relative to some of these others, but the rate of increase is really large. And so that needs to get under control, or else we're going to start to see a lot of deaths accumulate there. North Carolina, the rate of increase is not quite as bad as Arizona, but it's still not that great. Let me come and show you. Stop share here. So here's a dashboard. There's a few dashboards that I found really interesting. This one's the COVID Act Now website, and it shows things in one way. Basically, if you were to click on a state, so let's just click on New York as an example. So New York's infection rate, this R value, is 0.81, which demonstrates that the rate of new infections is decreasing on a daily basis. So this is great news. The positive test rate is another thing that we look at. And again, just to refresh people's memory, so basically among all the tests that are given out, and specifically they should be the viral tests, not the antibody test, but the active viral tests, that should be under 5%, and the lower the better. And because when you have a low number like what we see here in 1.4%, the only way you can get the numbers that low is if you are testing a lot of negative people. And so that means that these are people without symptoms. When the positive test rate is high, then that means that you're focusing the tests only on people who are sick, and it means you're not testing enough. So this is a really good indication that there's enough testing going on in the state of New York. And so this is great because it means that they're testing widely just to see if they can capture anyone that they might have missed, might have possibly been exposed, or someone that they might have missed, to try to ensure that they are not an active case. They're also this dashboard in particular is also following how much capacity there's left, and so New York is only at 24% of its maximum capacity for the intensive care units, so that's great. And then I like this one because it's also looking at contact tracing, and so New York is doing a really great job of contact tracing. So now so New York is really going in the right direction. They're not there yet, but they're going in the great direction. But in contrast, let's look at Arizona. So Arizona had an R value of 1.23. So that means that the cases are starting to increase. It's not the way that the R value was what we called the R naught right at the very beginning of the epidemic when we didn't have anything under control. Then we estimated the R value was around 2 to 3 or so generally on average. And so this is lower than it was because some people are still social distancing a little bit, wearing masks a little bit, but it's not enough, and it demonstrates that this is still increasing and it's not under control. The positive test rate, 13.9%, it means they are not testing enough. So in addition to it spreading, it's going to get worse because they're not even able to find all the people that are positive. Contacts traced, only 2% of people who are infected have their contacts traced. So that means this is just growing without any constraint. And then finally, right now, they're at 63% capacity in terms of the intensive care units, which means that as this continues to increase, they are going to blow past their intensive care unit capacity at some point. And so this is very concerning as we start to see in some states where they start. This was the major issue that we had in New York and New Jersey, and these hot spots that we had earlier a couple months ago. But now we're going to start to see this over the summer probably in some states that are approaching these bad.
Glenn, a big population of our audience is in New Jersey. Can you show us what's happening in New Jersey by contrast?
Absolutely. So New Jersey, the infection rate is 0.83, so that's less than 1, so it means it's reducing week by week. The positive test rate, 1.9%, great, because it means that 98% of all the tests are coming back negative, which means that there's a lot of people without symptoms are being tested. So that means there's widespread testing that's available and that's being conducted every day in the state of New Jersey. The intensive care unit headroom, we're only at 37% capacity. So there's lots of room in case there was another outbreak that we have enough spare capacity. We're not doing as well as New York in contact tracing. We're only doing a little bit more than a third. So this is something that it's a worry. We're going to need to work on that some more. And so luckily the testing is being done a lot, but the contact tracing is not sufficient. And this is a worry, because if someone's infected, if they exposed other people, how are they going to find out if they were exposed? In New York, because of their contact tracing, is doing better at warning people and reaching out to them in case they were exposed. In New Jersey, the majority of people who were exposed to someone who tests positive will have no way of knowing, unless the person reaches out to them directly. But in terms of having a systematic approach, it's problematic. And I think this is the main reason you see these other things are green. This is the main reason why New Jersey is coming in as a yellow risk level rather than the green that we're seeing in New York. Yeah, there's variation. So right now, according to this map, there's 3 states that are red in terms of what we're looking at. States that are doing pretty well, like New Jersey, but don't have contact tracing or other types of indicators, might be yellow. The ones that are at higher risk are at orange. The highest, of course, was the red that we just looked at. And then so you can see the distribution. So interestingly, Hawaii and Alaska were doing well. Alaska's not doing so great anymore. Let me go to a different view. So this is a state-by-state level. I think I like another view. This one's a little bit hard to see. Well, we can look at this for now. So this one is showing you in red the states that have a high caseload relative to where they were before. And so New York, or still just a total number of cases. New York and New Jersey and the Northeast are doing much better than they were. Maine and New Hampshire are still facing some difficulty. Other states that are standouts that are doing well, West Virginia, Montana, Hawaii are doing well. Alaska, you can see, is their curve is just going really far up. It's very, that reproductive value is not good. We're seeing in the West and the South a lot of red. Some of these numbers are just going way up again. In terms of, so we looked at this dashboard. I want to show you this dashboard. So this dashboard, I like the one that we just looked at because it incorporates contact tracing and some other factors. This one focuses more on testing and on the rates. Let me come down here in terms of the things. So the rates of increase, the test positive percent, and the ICU availability. Those are the major things. And when you just look at those criteria, then there's a lot of red. And this is, so this chart is biasing it more towards the increase that we're seeing across lots of states. And so when you look at it this way, because you can have an increase, but if you have really strong contact tracing and you have really strong testing, you can get it under control really fast. But you can see that these states do not have it under control in the South. Some of them are better than others, but according to the criteria set here, which was consistent with the federal government, the White House's criteria, these states in red are doing poorly. And so that's really bad. Let me see, there are a couple of other things. Whoops, give me one sec. All right, so this is just another view. Typically the ones that are in blue are the ones that are coming down. And you see that there's a lot that have not had a consistent downward. I think you have to be going down for two plus weeks in order to get that bar. And so a lot of states are not going down or not staying the same. We're seeing a lot of spikes in a lot of states. All right, so I'm just gonna, let's see, to go back to answer some of these other questions. Whoops.
Do you have data? Oh, that's exactly what I was going to ask on what's happening around the world.
Yeah, so a lot of states are doing really well. Some of them are smaller, but here you have Australia. It's wintertime there in Australia, so that's when we're really at risk. What we're telling everyone around the world, that's when people are really going to be at risk. And Australia is doing quite well. So they have it under control. They have the contact tracing. They have the testing. It's under control there. China is doing really well. They've had some spikes here and there, but because they've invested so much in contact tracing, they have contact tracing down to a science where they don't just have an individual that does the contact tracing. Instead, they have teams. So anyone that has that tests positive they have teams of 4 or 5 people that go and address that one person to see who they could have come into contact with and start testing everyone in the vicinity. And this is why China has it under control so much. Some other ones you can see: Estonia. We have some folks who live there who I think sometimes are on the call. Some of these countries are doing really well. There's a lot more in green this week than there were last week, which is great. There's less yellows this week. So some have turned green and some have turned red because they've had new spikes. So as an example, Israel was yellow for a couple of weeks, then it turned green, then it turned yellow, and now Israel is red again because they have another spike. And so this is not in control. And so this is something that they're going to have to get their heads around in terms of either whether it's locking down at some point or doing something, because it's right now going up and it's not under control. A lot of other countries, India was doing really poorly. Luckily, they're managing to get it more under control, so this is good. They've been really good at dramatically addressing this, but India still has a lot of worry, and they're not out of the woods yet. Similarly, so if we look at the United States as a whole, so this we have to keep on remembering that United States, the Northeast that got hit really hard, is continuing to come down as these other states in the West and the South are starting to come up. And so they still haven't quite passed. So the average is still now just starting to go up, where the South and the West are sort of compensating for the Northeast and the Midwest going down. And so this number is almost certainly going to just continue to go back up now. This was our floor over here. And so yeah, you can see a lot of countries out there. Russia has plateaued similar to the way the US was, but they still don't have it under control. You can see a lot of countries are still not doing great. What I've been following of interest is Brazil and South America, because it's winter time there. And what happens in the winter there is likely going to be what happens in the United States when we have winter, when we hit fall and winter. And you can see Brazil is just going right up. They have surpassed us. So over the past week, they passed the United States in the number of new cases per day. And they're currently getting 26 to 30,000 new cases a day. And so this is really bad. I think that before the end of the summer, or by the end of the summer, we are going to see what level people need to get infected at in order to get herd immunity in the country, because there's no constraint here. This is just going to continue to go up. And so we'll see. I mean, if this is the natural experiment that a lot of people in our polarized political system wanted to see, Brazil is going to just continue to keep on going up until they reach natural herd immunity. And will that be at 50%? Will it be at 80%? We don't know, but Brazil is going to tell us. And so, and at the rate that they're increasing, they'll hit it. They have, I think, what is it, like 200 million people or so, give or take, in Brazil. So at the rate of the exponential growth that we're seeing, they'll hit that before the end of the summer.
We have a question from Rachel Scherzer about what the threshold is. If you could remind us how countries move from the red to the yellow to the green, what is the determining factor here?
Yeah, so I think it's based on the total number of cases and how well they're doing. Like if you look at some of these, Japan, they're only have 41 cases. And so like some of these countries are really small, like the Holy See over here, like, so they have 0 cases, but on a day that they have any, it's like, I think this was like 1 case. They've had a total of 12 cases over here. So this is green. It's kind of silly almost to look at it that way, just because the numbers are so small, it's hard to compare. Something like Lebanon has 15 cases per day. So I believe the criteria were, it's not exactly, yeah, I don't know the specific criteria, but it's proportional to the size of the population and to, like, so for instance, a country like Germany, where look, this peak, they passed the peak, they're really in a good direction right now, but it's a large country, so there's still over 300 people infected per day. And so if they were to let their guard down, they could very quickly spike again. And so that's sort of why they're not quite there yet. Anyway, so let me go back. So this is where we stand as a whole. Let me go back to some other, to some other things that we've been seeing over the last week or so. One other thing I wanted to show was, before I leave, so here's one of the reasons that we know that the cases are going to get higher. So this was a video taken in Las Vegas this past week. And so I just want to show it because this is the most risky spread is indoors without a mask and without social distancing. And so here's, I don't know if you can see it. Oh, yeah, it's a little choppy. So this was last week in Las Vegas. This was just a random day in Las Vegas. And so you can see hardly any mask wearing. It's an indoors area, so it's not very much social distancing. There is going to be a lot more COVID-19 that's spread because of these areas. And so, so this is enough. It just goes on.
Blackjack table, Glenn?
What's that?
Isn't that you right there at the blackjack table?
Nope, I am not in Las Vegas. But so I'm going to stop this. But so this is disconcerting, and it's really problematic. So so this is something that we need to, that is going on at the same time when we have the protests that we'll probably talk about in a little while, and all these other public areas. Being outdoors is way more protected than being indoors. Social distancing matters, and wearing a mask matters. But this indoor exposure is really, really dangerous relative to outdoor exposure.
So let's go there. Let's talk about the protests. I know that we typically keep politics out of the conversation, but the protests in general, what is going on from a public health perspective? The public health community has repeatedly said that people should avoid large crowds. So why do epidemiologists seem to have a double standard here? What is your take on the protests, and what can we expect to see?
Good question. So so here's what we're looking at. First of all, so racism and race, let's separate those two issues. So a person's race is their skin color, their ethnicity is more of the cultural aspect of it, and race is more of like the genetic component of it. And so everyone has both a race and an ethnicity. And so when it comes to racism, there's two major reasons why epidemiologists believe that these Black Lives Matter protests are important. The first is for COVID-19. So here's an example of risk associated with being Black in the United States with COVID-19. So Blacks are much more likely to get infected with COVID-19. Among those that are infected, they're much more likely to be hospitalized with severe illness. And among those who are hospitalized, they're more likely to die from the disease. And there are a lot of reasons for this. So I'm going to open this up a little bit and just unpack everything. Another way of looking at this is, and so going back to this question, it seems like a double standard. The way I look at it is, we know that another large risk, another group that has a high risk factor are Medicare age people. So people over the age of 65 are at much greater risk of having severe clinical disease from COVID-19 and of mortality. And so if the country wasn't addressing it and wasn't protecting people over the age of 65, then we would be having these protests to support people over the age of 65 too, where we'd want them out in the streets and want them to be safe and want the country to do something to protect everyone who's over the age of 65. Our country has been doing a pretty decent job. I mean, we see some of the variation across the states, but we know that people over the age of 65, we're treating these people as if their lives matter based on the risk for COVID-19. But we're not doing that based on race. And so because of that, it makes sense to be doing the protest. Let me go into this just a little bit deeper. So far, roughly 1/4 of all the deaths for COVID-19 in the US are among Black people. And that is a far larger percentage than the percentage of people in the United States who are Black. Black people are dying at nearly twice the rate of people who are not Black. This is huge. When you look at racism around the country, so this is not the distribution of race, this is the distribution of racism. And so the prejudicial attitudes, structural, well, I'll get into the different types of racism in a second, but you see that there's differences of exposure to racism, right? What we're looking at here is a map from the Southern Poverty Law Center. There's a couple other maps here. This one is the use of racist language on Twitter. You see it's not equally distributed. The risk actually varies by different parts of this country. Here is racist places based on Googling terms. These are very, very crude proxies for this idea of racism, but still it's interesting looking at the map of it. I'm gonna skip to here. But before I go on any more about racism, so public health is convinced that all lives matter. It's not just a question of whether Black lives matter or not, all lives matter. And one thing I keep wanting to point out is that Republican lives matter too. And one of the problems that we're seeing because of the poor communication of the federal government right now, or the inaccurate communication, is that we're seeing wide variation in in belief about social distancing. So Democrats right now are far more likely to believe that social distancing is worth it than Republicans are. There's this huge variation based on what people are hearing. So Democrats are hearing, it's almost like become a polarized COVID-19 messaging of what people are hearing in terms of the importance of social distancing. And so the next thing I'm going to show you is, well, what's the impact of that? And already we're actually seeing in real life, this is not just ideas, this is not just a poll anymore. Now we're actually seeing difference in behavior. And so what this means is, so when you look at social distancing, after we started opening up, you see that Democrats are continuing to social distance as much as they were, or more so in some ways than before, whereas Republicans have decreased their social distancing dramatically. So there's a major difference, statistically significant, between Democrats' approach to the post-COVID-19 lockdown versus Republican approach. And this is really dangerous. We don't have I don't know that anyone is currently tracking differences in hospitalization rates or death rates of Democrats versus Republicans, but this is really scary. We should be encouraging Republicans, because their lives matter, to socially distance and to wear masks and do this stuff. But right now, Republicans are at risk, and so not enough people are paying attention to that too. But now let me jump back into the Black Lives Matter questions. So there's something really interesting that a lot of people haven't realized before, and that racism isn't just a social disease, it's actually a clinical disease. It has biomarkers in Black people. So it's Black people are born with certain genes and certain biophysiological makeups, but racism actually changes all this. It actually has biomarkers of disease. So first, let me just say what racism is. It occurs in 3 general ways. Some people who, and not everyone who's Black experiences racism in the same way. Some people are Black and they have privilege. Racism is just more likely to affect people of a minority race. And in this country, we have a long history of racism against Blacks. And so even though there are lots of a whole range of skin colors and people of different backgrounds and ethnicities, Blacks in particular have a long history in the United States of racism. So when it comes to among Blacks in this country, there's 3 major types of things that we're looking at. One is some people experience a major event in their life, a crisis where they felt that they were a victim of racism. For other people, it's more of an everyday discrimination type of thing, where their dignity and respect is chipped away. and there might be unconscious discrimination against them, but it's just some things that they feel. And then there's also institutional discrimination or structural discrimination. So for instance, maybe Blacks are grow up in poor households, and so the kids in the household have less opportunity to get into the better schools and to get into the better jobs. Maybe because of where they're living, just the physical location of where they're living makes it more challenging if the better jobs are miles away, and maybe they can't afford a car. And so there's structural aspects that prevent growth. And it's just a historical residual artifact of where our country has been that you can just trace it through history, and it continues to be a problem. So I'm just going to not just spend a few more minutes talking about this area, but here's some really interesting biomarkers of racism that have been found. So these are all physiological things happening in our bodies that these things can be evaluated in all people. And so you can literally look at these things in different people to see if they're being impacted by bigotry, by other types of things. So the four things are telomere shortening, allostatic load, hypothalamic-pituitary-adrenal dysregulation, and epigenetics. I'm just going to jump through them really quickly. It's a fascinating area, but the most fascinating thing for me is that there's biomarkers at all. This is not a social disease. Everyone thinks of this as a social issue, and it is a social issue for sure, but it's also a clinical disease. And so let's go into some of these things. So the first, telomeres. You might have learned about this in high school. So basically, telomeres are these genetic, they're things at the end of the chromosomes. So when cells replicate and separate, these telomeres are these things that end the chromosomes. And it's a genetic level. So these are genes, and the chromosomes connect all these genes together. And at the end of these gene groups, you have these telomeres. And telomere shortening is associated with longevity. And so over our lifetimes, our telomeres get shorter and shorter and shorter until we get old enough that all sorts of diseases, the likelihood of the diseases increase dramatically. Cardiovascular disease and cancer and all sorts of things. This has been known for quite some time. But so among Blacks, what we realized is that Black people who are the same age as non-Black people tend to have much shorter telomeres. And this is not something that's just, so the genes, they're born with the same genes that they were born with, but some Black people, again, this is not all Black people, this is just the ones who have had the most racist experiences against them. It impacts them and actually impacts their cells at the cellular and genetic level. So another thing, and so this has been studied, people with high racial discrimination, their telomeres go way down relative. I mean, this is astonishing. This is not a genetic thing that they were born with. This is racism. It's a biomarker of racism. Another thing, allostatic load. So when you look at biomarkers in general, so when you look at blood pressure or pulse or the body mass index or cholesterol or some of these other things like the glycohemoglobin and serum albumin, the C-reactive protein, all of these different things, when you look at them together, it's called the allostatic load. And it's this idea that physiologic processes in general might change over time based on stress. And so the people are experiencing. And again, all of these things are looked at not just for the impact of racism. You can find it for bigotry in general, but in racism, it's definitely been evaluated and it's been identified. And so allostatic load is another biomarker. Epigenetics, it's so interesting. And so there's actually changes at the genetic level that we're finding among African Americans. So people who are, and this isn't all Blacks again, this is just the ones who experience the racism to a higher level. When they go through life and they have these epigenetic changes, then they might be the same age and they might even have the same disease, but even with the same disease, they're more likely to have a more severe version of the disease. So they might have rheumatoid arthritis with way more severe chronic pain versus someone who has rheumatoid arthritis and doesn't have a severe pain. They might have more depression or other kinds of things. It's really interesting. It's actually changing the genetics. And then finally, I'm going to talk about the HPA axis, the hypothalamic-pituitary-adrenal gland axis. And so basically, this is something that's been studied for a couple of decades now, I think. And so basically, it's sort of, how could racism even get into the body to have an effect that's a clinical effect at all? And one of the ways it can do this is through the brain in terms of the perception of racism. There's actually a whole pathway that's been identified that triggers different responses in the body. And so there's multiple clinical pathways that have been identified. The key point I'm trying to make here is that racism is a clinical disease and not just a social disease. Okay, so I'm going to leave that here. So now let's circle back to these protests. So there is a worry. Going to the protest does increase people's risk, and this is really worrisome. And so that means that we need to worry about mitigating risk for people who go to the protest. We need to think about how can we reduce their risk. And so the very first thing that I would tell people is, if you've been to a protest or you plan to go to a Black Lives Matter protest or any protest for that matter, and you're going to be around large people, but in particular, if you go to a Black Lives Matter protest, because there have been so many people, it is critically important that you get tested. And if you go to multiple Black Lives Matter protests, you need to get tested multiple times. You should be tested at least once a week. And if you test positive for COVID-19, or you have any symptom at all, not just the respiratory symptoms that we thought at first, but headaches or gastrointestinal issues or some of the neurologic symptoms that we had been talking about, in addition to the respiratory symptoms or fever, if you have any symptom at all, you need to quarantine yourself and not go anywhere for 2 weeks, and certainly not go to a Black Lives Matter protest. And the reason is Black Lives Matter. And if you care about Black lives, then you do not want to get anyone else sick at one of these protests, and you don't want to be the cause of a Black person dying. So I don't care who you are or what your race is or what your thoughts are. If you have any symptom at all, or you test positive, but even if you don't test positive, if you have any symptom at all, do not go to a Black Lives Matter protest for at least 2 weeks after the symptoms have resolved, so that you do not infect anyone else. All right, so that has to be clear. All right, now if you do go to a protest and you're symptom-free and you don't have to worry about this, then we're not quarantining because we've already, like I said, if you have any symptoms, that's what you do first. Now, if you go, absolutely wear a mask and keep the mask on. Bring extra masks and give it to anyone who doesn't have one. Everyone at these protests, without exception, needs to be wearing a mask, including people on both sides of the protest, people protesting and also the police and other people on other sides. Everyone needs to be wearing a mask because this is so important. It's been found to be so helpful. The next thing is stay as far apart as you can, preferably 6 feet apart or more, but it doesn't necessarily, there is an exception here. If you live with a few housemates and you all live together, your household exposure will be the same either way in terms of what you're looking at. So if you all go together to one of these protests, you can stay close to each other as long as you stay away from other people. As long as your cluster is together and you stay further away from other people, then it doesn't matter so much. You don't have to be 6 feet away from each other. So you can cluster together if you already live closer together and you're already in each other's either household or you're not at increased risk. Make sure you use hand sanitizer and don't yell and risk sending the COVID-19 out if in case you're infected. Instead, use other noisemakers or other things if you have to. But again, the most important thing is, if you show any symptom at all, even if it's not respiratory, any symptom at all, you owe it to the cause to stay home for at least 2 weeks. So that's the most important thing. All right, I talked about Republican lives mattering, and that is pretty much it for that.
Glenn,
The one other thing before I go on, one other thing. So chains of infection, and this is such a critical thing. It's peripherally related to race, but applies for everyone to think about. When we think about COVID-19, a lot of people are thinking about our personal risk. What is the risk? What is our personal risk of getting infected, or our personal risk of getting hospitalized if we are infected, or our personal risk of dying if we're infected? And that is absolutely the wrong question, because let's look at these pictures. Let's assume, I just grabbed them off the web. I don't know who these people are. There's probably for different advertising campaigns. But for the sake of this illustrative discussion, let's assume that this person is now infected with COVID. This person in this scenario infects this person behind them and infects this person behind them. And then this person infected this person and this person died. And this person infected this person behind them and this person died. So this person, instead of thinking about themselves, what's their risk of recovering and surviving, their risk was probably pretty low. They look somewhat young and not at high risk perhaps. And so their risk was not so high personally of them getting it, but because they got it and were not conscious enough about who they might be spreading it to, people died because of them, because they didn't take the precautions they should have. Like, people literally died because they didn't take the precautions they should have. So when we talk about us not getting infected, it's not about us. It's about us not getting infected so these people don't die as part of these chains of infection. We need to consider all of these things to be chains of infection. So any one of us that gets infected has a whole chain of people behind us, and it's our responsibility to break the chains. And the easiest way to break the chain is for us not to get infected at all. And this seems to be lost in the whole communication process that's going on with the public health systems right now, is that it's mostly the communication is about our personal risk. And it's not about chains of infection and people that might be dying because of us and because of our willingness to get infected, for instance. So this has to be it's always these chains of infection. One person infects the next, who infects the next, who infects the next. It's a virus. A person who's 70 years old won't just die from COVID-19. They will catch it from somebody else. We need to break the chains of infection. All right, that's it for that.
So Glenn, you talked about the test, the COVID-19 test, and certainly getting that if you've been to a protest or out and among other people. How accurate are we finding that test to be these days? And separately, should everybody now go and get this antibody test? Is it readily available? And I've heard sort of different numbers out there about how accurate it actually is. So should we bother?
Yeah, so one of the problematic things is because there were a shortage of tests at first, the FDA basically approved all the tests. And so now there are lots and lots of different, these antibody tests are called serology tests, and there's a ton of them out there. They vary dramatically in terms of accuracy. Some have stronger false positive rates, some have worse, some have better false negative rates, some are worse. The accuracy for many of them is really poor. And so on a personal level, it probably doesn't make a huge difference. When the whole question is, what are you going to do with the results? And we should all probably still continue to assume that we have not been infected. So even if you have a positive antibody test, which would suggest that you were previously infected, it could be a false positive. And so I wouldn't necessarily say that that's an excuse where you can take off your mask and you can just go in public and do whatever you want. Conversely, the difference between the viral test, this PCR, the polymerase chain reaction test, and the antibody test are the virus tests tell you if you have an active infection, whereas the antibody tests don't tell you if it's an active infection or not. So you could have a positive antibody test and still be contagious. It doesn't tell you that you've cleared the virus or not. All it tells you is that you have a serological response in your body, you have an antibody response, but you could still be contagious. only the virus test tells you if you're contagious or not. And even that has a false negative and false positive rate. So because of that, it's still useful for, I would say, for public health understanding, for testing wide swaths of the public, looking at changes over time at a population level. It's still very useful for that type of reason. But in general, for on an individual basis, I don't think we can really trust it enough right now to interpret a result one way or the other. So I think that they're not accurate enough, and I would not use a result to interpret it one way or the other on an individual basis. The one other thing is this idea of protective immunity. We're still not 100% sure that antibodies are providing 100% of protective immunity, because we do know that there are some types of antibodies that can be produced that will give you a positive antibody result on an antibody test that don't actually protect from COVID-19. In fact, some might actually make the disease even worse. In SARS-CoV-1, so the original SARS that took place 15 to 20 years ago, what we found in some of the vaccine studies that were done to try to create these antibodies is that unfortunately, some people who developed antibodies actually did worse than they would have if they had no antibodies at all, because it created an exaggerated immune response that was even worse than not having any antibody. So we don't know yet if having an antibody is protective or not. So that's another reason that we just don't know how to interpret it yet. We're still figuring that stuff out.
Thank you, Glenn. That's really helpful. It seems like this week there's been a lot of talk about the polio vaccine, and could that be a useful instrument in preventing COVID-19? What are you hearing about the polio vaccine?
Yeah, so this is a good question. And so we have seen this question come up a bunch of times over the last few months, or a similar question. So the first one that we saw was the BCG vaccine for tuberculosis. Similarly, for the polio vaccine, it's what we're finding is that there's typically vaccines that are produced are very specific for to generate specific antibodies. And it's the antibodies that provide the memory, the immune memory, to attack a disease. But what's curious about the polio vaccine, and also is being investigated in the tuberculosis vaccine, and also with the common MMR vaccine, measles, mumps, MMR vaccine, they are generating not just an antibody response, but they also seem to be stimulating the innate immune system. And so because of that, they've been investigated for other types of diseases to see if they prevent those diseases. And they have been found to have some clinical protection for some other respiratory diseases. And so because of this, there's interest. Right now, it's just at the point of interest. For the tuberculosis vaccine, and also now for polio, there were strong correlations found. Just correlations, but showing that among states with heavy vaccination programs, they were much less likely to have lots of mortality from COVID when they were hit. And so it was very intriguing. There are now a lot of clinical trials that are going on. Unfortunately, what we found was that the correlations didn't seem to necessarily be very strong when we looked more deeply. What we found was that there was a founder's effect, and typically the countries who had the vaccination policies were also the ones who tended to close down first and close down sooner. And so as a result, the lockdowns themselves were preventing the spread. And so it was just a false correlation, but it's still intriguing. There is still this intriguing hypothesis. So there are vaccination trials that are ongoing with tuberculosis, and we should find the results of these trials within the next 3 months or so. So we're going to find those pretty quickly, much quicker even than the antibody tests that are going on, or the antibody vaccinations that are going on specifically for COVID-19. So this is something that a lot of us are keeping an eye on for. The interesting thing is that these vaccines, this long-term safety profile of these vaccines are well known. And so as a result, with the COVID-19 vaccination programs, there's a real worry about safety. And that's one of the key things we're going to be investigating. Whereas with these vaccines, the polio and the tuberculosis, they've been used for decades. And so the safety profile is very well known. And so if there's clinical success, there's efficacy, then within just 3 to 6 months, we could get a lot of people vaccinated with these vaccines. So that could be really good. There's one other thing. Before you ask your next question, Becky, one other thing I wanted to talk about, I skipped over a little earlier, just real briefly, and this is political retribution against scientists. We're starting to see more and more of this across the United States, and this is a little bit scary. So epidemiologists, data scientists, other public health scientists are being asked in some places to forge the data because the political system, in the government, wants it to seem like there are less people being infected or that COVID-19 is not as bad in their state. Over the last week or so, in Florida, someone was fired. This woman, Rebecca Jones, was fired in the last 1 to 2 weeks. And the reason was she created this map. The state of Florida wanted to reopen and end the lockdown. And so she created a series of maps to show if the state was ready to open up again. And so based on the criteria that the state had agreed to, what she found was that only 2 counties were ready to open up. And so the state got really got upset. And they told her to fudge the data so that they could open up and make it seem like that the greens were everywhere instead of it being all red in the state, because they wanted to open up without anyone knowing. And so this woman refused to fudge the data, and she was immediately fired. And so now this is really disconcerting, because how many other people are out there who are asked to fudge the data and they're now fudging the data? One of the things that they were fudging the data on when they opened it up is this thing here. And so apparently Florida, whoops, let me put it over. Florida was one of the ways that they're continuing to fudge the data this way is that one of the key things that I bring up over and over again is the percent of tests that are positive. And there's 2 ways that we found that people are fudging this data. The first we found a few weeks ago, where some states and geographies were combining, even the federal CDC was sort of scamming us with this. They were combining the viral tests with the antibody tests to put them all together in the denominator as the percentage of tests, when really it should just be the virus test that's important. But if you make the denominator really, really big with the antibody tests in there too, then it makes it seem like your percentage that's being tested is really good. And so, but it's a way of fudging the data, because really it should only be the virus tests in the denominator and the positive virus tests in the numerator. And so another thing that we're doing, and this is what happened in Florida that's also really bad, is Florida is reporting that they have currently around 5.5% positive rate on their tests. The problem is, if someone tests positive, then they count that person as a test positive in the numerator, but in the denominator, they include the total number of tests. And in the state of Florida, around half of the tests have at least have more than one. Let's put it this way: at least half of the tests are among people who have been tested numerous times. So, for instance, if you're a nurse in a hospital, you may be required to get tested every single week to make sure you don't have an infection and you're not infecting your patients. And so if you're being tested every week for months, then that denominator is going to be huge. You could continue to be negative. The denominator is huge. Whereas if you turn positive even once, then you go into the numerator. And so it's not telling us what we think it's telling us. It's impossible to interpret what it's telling us, because basically it's not telling us what we think it is. What we want it to be telling us is the test positive rate, the percentage of people who are positive, who are getting positive results among all the people tested. But if you increase just the total number of tests, and a lot of people are just getting tested over and over and over again, so you have all these massive numbers of tests, then it makes the fraction seem really small. It seems like you're doing well. but it's just fraud. It's just simple. It's a simple scam because some states want to open when they're not ready to open. And sure enough, here's what we're seeing in the state of Florida. We're seeing an uptick in the number of new cases. They opened before it was too soon because they scammed the public. This was the government falsifying the data, and now we're seeing an increase. And you can't, this increase is going to have an increase in hospitalizations and an increase in deaths, and that's not something you can fudge. Once you start having more people in the intensive care units, you can't fudge that data. And this is just a consequence of these bad decisions that these people made. And I don't know how much this is occurring in other places. We know about this because this person was fired and she took the data and she made her own dashboard. So there was the Florida dashboard, and then she made her own website of the dashboard, and that's how we found out about this. But we don't know where else in the country this is going on, and it's really problematic.
Wow. I don't know what else to say other than, oh my goodness. How fortunate we are that we have you showing us the data and interpreting the data for us. Holy moly.
I am glad to be here for everyone.
Thank you. So do we know anything new about asymptomatic people and how contagious they are? I know we've been talking about them for quite some time. It seems to be general consensus that we can get sick from someone with or without symptoms. Has anything been uncovered about those asymptomatic folks?
Yes, so let's talk about this because there was a big thing. Let me share my screen again. There was a big question over the last week. The World Health Organization came out with an announcement, and their announcement was asymptomatic spread is virtually non-existent. It's a tiny portion of the spread. And that was extremely confusing to people, and it was really essentially wrong in the way everyone heard it. Because what most people heard who were not epidemiologists, most people, what they heard was that if someone in front of you had no symptoms, they did not appear to be sick, they appeared to be completely healthy. If the person in front of you had no symptoms, then you couldn't get the disease from them. And that was exactly wrong. That was not what the World Health Organization meant. That was not communicated well, and it was bad. And so because of that, a lot of people seem to have heard that it was okay to go out as long as the person wasn't coughing near you or had a fever or something, but it's not true. The key difference is this idea of asymptomatic versus pre-symptomatic. So everyone who eventually gets sick will get, so everyone who eventually gets symptoms, let's say, goes through a period, an incubation period, where they don't have the symptoms, where they currently have no symptoms before they end up with symptoms. And we call that the pre-symptomatic period. And so the person standing right in front of you could have no symptoms at all. They might feel perfectly fine, and they could be completely contagious. And in fact, we estimate that maybe 40% of all the spread of the disease from one person to the next is among these people who are contagious but have no symptoms. So they're pre-symptomatic, not technically asymptomatic, because they are asymptomatic, but I like to call them pre-symptomatic instead, and differentiate that from someone who's asymptomatic, who never gets any symptoms at all. So there are some people who get infected, then they go through weeks until the virus is completely cleared, and during that entire time, they've never had a single symptom at all. And that's asymptomatic, and the spread from that type of person seems to be quite small. And so from a public health perspective, this is great news, actually. And that's why the World Health Organization was so enthusiastic to find out about this. And the reason is when you do contact tracing, it's very, very hard to do contact tracing for asymptomatic people. So if asymptomatic people are spreading it to other people, to other people, to other people, and a lot of them are asymptomatic throughout the whole course of the disease, then it's very hard to do the contact tracing. But if everyone who was pre-symptomatic eventually gets symptoms, then they will be identified to the public health system because of their symptoms, and they'll be tested, and they'll be much, much easier to then identify and contact trace. So from a public health perspective, it's amazing news to hear that the majority of people who are spreading the disease eventually get symptoms. But if you're hearing it as a person, I could understand why some people perceived that if there was a person with no symptoms in front of you that you couldn't catch it, but that was false. Yes, pre-symptomatic people are spreading the disease like crazy. And so just because someone has no symptoms does not mean anything. They could still be contagious, still be infecting you. And the same thing with you. Remember, we have to stop these chains of infection. So just because you have no symptoms doesn't mean you have no virus. You could be infected and could be infecting other people without knowing it, just because even if you have no symptoms. That's why you always have to wear your mask and always have to socially distance, because it's not just about you. It's about breaking the chain of infection.
Thank you for clarifying that, Glenn, for us. I know that's been a hot topic for quite some time, and now we have the answer. So it looks like we're kind of about time wrapping up. Do we have time for one more question?
Sure. You want to either open it up, or else I have a positive question to end on?
Okay.
What do you want to, are there any other questions online, or else we can just end it here?
No others have come in so far. We have just the one more that came in during the week about, does COVID-19 impact male fertility? All
right, I can touch on that one briefly and then do this last one that's more of a positive note. So this was the polio vaccine. Oh, where was this? Oh, here it is. So this is still an open question. I don't have an answer for this yet. What we do know, so we know that SARS-CoV-2 infects the ACE2 receptor. And we do know that ACE2 receptor expression is very high in male in testicles. And so there has been a worry that there's all sorts of long-term consequences to SARS-CoV-2, to COVID-19, that we have no idea what they are yet, because we haven't been investigating them. Like we're just getting over this first acute outbreak period where we're just trying to keep people alive. But now there's a lot of people who are out there with long-term symptoms where they've gotten through most of the disease, but some people continue to have headaches. Some people continue to have fatigue and other symptoms. And there's probably a lot of other things still going on in people's bodies if they were infected that we have no idea about. So when it comes to male fertility, one thing that we've identified is that, I don't have a link here, but SARS-CoV-2 has been identified in human semen, in male semen. And so that means that right now we've identified it. We don't even know if it's active or whether it can infect other people. It's almost like an STD type thing. We just know that it's there, it's being excreted there. And if it's there, then that means that it could easily be replicating in the ACE2 receptors of these cells in the testicles. And so there is a serious case to be made that male fertility could be dramatically impacted among people who get SARS-CoV-2. We don't know the answer yet. This is just one of these open questions. There's a lot of them. And that I keep coming back to this when I have conversations with friends and family, is that the outcome that a lot of people are thinking about is death. And so they say, oh, well, 98% or more of the people who get SARS-CoV-2 or COVID-19, over 98% of them recover. But the reality is, among the ones who get sick, we don't know what the long-term consequences are yet. And so it's still an open question. And not just this, but a lot of we know that the ACE2 receptor is found all over the body, and we don't know the long-term consequences, so we're still figuring it out. But Becky, I'll end it on the high note based on what
we're ready for some good news. Yeah.
Okay. So here's the good news. So we've talked about previously the innate immune system versus the adaptive immune system. And when we talk about antibodies, and that's the sort of memory, antibodies are just one type of adaptation that can occur in the body in terms of the immune system. And all of the vaccines that we're looking at for COVID-19 are all antibody vaccines. Whereas the ones that we just talked about a little earlier, the polio vaccine, the tuberculosis, etc., those might be having an effect based on other parts of the immune system that are not antibody mediated. And there's been some interesting work released over the last week or so. This was actually a little bit older, so over the last few weeks, looking at T cell mediated immunity. So immunity, so what we're looking at here is a picture where these T cells go and identify cells that are infected with SARS-CoV-2 and then attack and destroy the cells. And so it's another way of the immune system attacking the viral spread without actually even using antibodies. And what they found is that everyone who was infected with SARS-CoV-2 in a sample that they looked at, it was a small sample, but everyone that they looked at had helper T cells and killer T cells. So everyone had helper T cells, and 70% had killer T cells in terms of the, attacking a development as part of their immune system. And so the good thing is, and this is really good, approximately a third of the people who were uninfected also have T cells that can fight this disease. So when we look at susceptibility, at the very beginning of this disease, we thought 100% of the people were susceptible. And now we think that that's less because some people have already been infected, and we assume that the antibodies are mostly protective. But what we're seeing now is that this might be a reason if these T cells have this memory, then a third of these people could have been infected from other things. There's something called cross-reactivity, and we know that there are other coronaviruses circulating, much more. So for instance, the common cold contributes to the coronavirus spread, but it's not a significant disease because it just causes cold symptoms. And so there's a bunch of things that cause the cold, and we don't really pay a whole lot of attention because it's just the cold, so who cares? But when it spreads, it activates the T cells. And so this is great. What we haven't done is done the next step. We don't actually know if the T cells can actually prevent or end an infection. We're still trying to figure that out. A lot of people are actively looking. But the fact that there is a T cell memory with this cross-reactivity that could be helpful is really, really good news. In fact, when they looked at some blood samples that have been stored from well before when SARS-CoV-2 started spreading, so these were samples from 2015 to 2018, they found that around half of the stored blood had coronavirus memory in their T cells. And so that means that there is a chance that the susceptibility level might be less than we thought it was, and herd immunity might be achievable at a far lower level. So this is great news. We don't know for sure yet, but this is the first indication that there might be some more protection out there. And so we're heavily investigating this, but I would definitely say this is potentially very good news. That
is very excited, but we are going to be cautiously optimistic. It sounds like that's what you're telling us.
Exactly.
I think I speak on behalf of the group that we look forward to hearing more about T-cell mediated immunity. So please continue to stay focused on this, and we like this good news you're bringing to us. So thank you, Glenn. Thank you on behalf of the group here today. And always, we appreciate you sharing your time with us and your knowledge. And, who's with me? And as always, send us questions during the week. If you have questions, it helps us prepare for the next week's session. And can we expect to see you here again next Sunday, 7 o'clock, same time, same place?
Sounds great. See everyone at 7 o'clock next week. Thanks a lot for joining us.
Thank you. Thanks.
All right, bye-bye.
Yeah, stay safe.